All right, welcome back. For this video, we're going to be talking a little bit about why sometimes it's easier to prove something rather than disprove, or prove a negation rather than disproving a statement. So let's take a look at what we're talking about. What the heck are we talking about? So here, this exercise is asking us to disprove the following statement. And let's just break it down. For all m greater than 0, oh, I hate when that happens. There we go. For all m greater than 0, there exists some n not greater than 0 that for all of the n's greater than said n not, this statement is true. M times n cubed is less than n cubed plus 2n. Now, we might look at this and tell ourselves, okay, this actually won't be that bad because we only have to find one value that potentially exists. And then everything else has to just follow suit. So as long as we can pick an n not greater than 0, we need to be able to prove that for all arbitrary m's and n's, that the inequality shown is going to hold true. But today we're going to actually be more specifically talking about why it might be easier. Sometimes it's easier. Let's say this is statement S. Sometimes proving not S is easier than disproving S. All right. So knowing that this might be the case, that's exactly what we're going to try to do. Now we're allowed to do this. We're allowed to prove the negation because the negation of the word disprove is going to be prove. And so then the negation of S is going to be not S. So let's go ahead and do that. Let's negate our S statement. And by doing so, we end up negating for all m greater than 0, there exists an n not greater than 0. For all n greater than n not, that this holds true. Oh, I'm going to run out of space. Let's move that whole thing over. Okay, plus 2n. Okay, so what does it mean to negate this whole thing? So now we're going to say that not s is going to be, we have to flip those quantifiers. The problem space doesn't change in terms of like the number space, so that stays as a greater than 0, but we do flip the for all into a there exists. And we do that for each one. So for all and not greater than 0, there exists an n greater than n not. And then let's negate this whole thing. Mn cubed is going to be greater than or equal to n cubed plus 2n. There we go. We have negated that. All right. So this becomes easier because we now know that we need to find an n greater than n not. So let's just start by taking a guess at that. What could it be? Well, since we now know that for all n not greater than 0, this is true, we have an n not already defined. We can just say let n equal n not plus 1. That's greater than 0, right? No problem. Let's just start there. So the next thing we're going to do is we're going to observe the fact that n cubed plus 2n is less than 3n cubed, right? That seems to make straight sense for us because if we can somehow turn this into an n cubed, this is kind of like a 1n cubed. And if we can say 1n cubed plus 2n cubed, that's going to be less than 3n cubed. So we're going to round up just like we like to do. And when we do that, we can also all of a sudden observe that 3n cubed kind of looks like mn cubed. And why are we allowed to do that? Well, because we're proving the negation, we just need to prove that an m exists. So why not pick m equals 3? Why not? Let's see what happens. 1. Let m equal 3 and let n equal n not plus 1. Since we just proved above through rounding up trick that n cubed plus 2n is going to be less than 3n cubed, and we can say 3n cubed is equal to m. n cubed because m equals 3, right? This could be 2. This can be 3. This is true by 1. Given all that information, 4, we can say by 2n cubed plus 2n is less than 3n cubed, and by 3n cubed is the same thing as saying this. Because of 1, it follows that n cubed plus 2n is less than m n cubed. And we've proved it. That's it. It is that easy. Sometimes it's hard to know when you need to negate something. Often disproving something does feel a lot harder than proving it. So if you see the word disprove, you might want to try negating everything and try to prove it instead. But when in doubt, you try one way, and if it doesn't work, perhaps you flip it and try a different way. This is a nice short video, thank goodness. We've gone ahead, we've done our official proof here, and that's all there is to trying the negation of a disproof statement. Hope everyone has a great day, and I'll see you in the next video. Thanks all.